In section 3.2, we will solve systems graphically. The goal of the lesson is to solve a system graphically. Systems of equations can be solved in the following ways. We can solve them by graphing, by substitution, or by elimination, and the focus of this lesson will be on graphing. In the first equation, y equals negative 2x plus 1, we start by plotting that y-intercept at 1. From there, the slope is negative, so we know that it's going to go down as we move left to right. It will go down 2 and over 1, so we can make that second point. We can continue plotting points throughout the graph or use a straight edge to come up with the line. For our second equation, we will start with the y-intercept at 4, and that has a positive slope, so we will see that it's going up from left to right. It's going up 1 over 1, and that ends up looking like that. Wherever they intersect is going to be the solution to our system. So this one is at negative 1, and then we go up 1, 2, 3 units. So we are going to be at negative 1, 3. And then we want to test that value for both of the equations by plugging in the negative 1 for the x in each and plugging in the 3 for the y in each and seeing if it gives us a true statement. So for the top equation, I'd have 3 is equal to, that would turn into a positive 2 plus 1. Therefore, I get 3 equals 3, which is a true statement. For the bottom one, I would get 3 is equal to negative 1 plus 4, which again would give me 3 is equal to 3, and that means that that is the correct answer here. For example 2, with y is equal to negative 1, when I plot that, it is going to just be a horizontal line passing through the y-axis at negative 1. My other equation is going to start up at positive 4 and then go down 5 to go to the right 2, or I could have gone up 5 to go back 2. Either way, that will be the line. And the point where they intersect is going to be our answer. So it looks like we go over 1, 2, and then down 1. So we're looking at an ordered pair of 2, negative 1. Once again, we want to check that. When I plug this into the top equation, there's nowhere for me to plug in an x, a 2. So that means that I would just plug in the y value and I'd have negative 1 is equal to negative 1. Since that's a true statement, it's good for this top one. For the bottom one, then I'd have negative 1 is equal to negative 5 halves times 2. The 2's would then cancel, so I'd have negative 5 left and then plus 4. So that means I get negative 1 is equal to negative 1, which does confirm this as the correct answer. In example 3, we start with the top equation. I'm going to plot that point at positive 2 on the y-axis, and from there go down 2 and over 1. We can sketch that line. And then for the second equation, we start at negative 2, and this one also goes down 2 and over 1. And so we sketch that line. And what we came up with here would be parallel lines. And parallel lines, by definition, will never intersect. And so since they never intersect, that means we're going to have no solution to this problem. And we could have recognized that from the very start when we noticed that the slope was the same, but the y-intercepts were different. For example 4, we're going to start at positive 1 on the y-axis, and from there it's a negative slope, so down 1 to the right 1, and sketch that line. The other equation will start at negative 3, and we will go up 1 and to the right 3, or we could go down 1 and back 3. Either way, we should get that line. Once again, wherever they intersect, that will be our answer. So this one looks like it intersects at 1, 2, 3, negative 2. So 3, negative 2. Now I need to test that value. So as I plug this back in, I'm going to have negative 2 is equal to, this will become a negative 3 plus 1. Therefore, I get negative 2 equals negative 2, which is true. For my bottom equation, I get negative 2 is equal to 1/3 times 3. Therefore, the 3's cancel, and I get 1 minus 3, which also gives me negative 2. So since it worked for both equations, that is going to be the correct answer. And your homework for tonight is going to be a Delta Math assignment on solving linear systems graphically, and it's level 1 in algebra.